Hello friends, welcome back to Triple tutorial channel. In this video we will see rectifiers. Mainly we will discuss about half wave rectifiers. Okay. We will see the working of half wave rectifier and the working of half wave rectifier with the filter, and we will see some important parameters related with half wave rectifiers. And finally, we will see what are the major advantages, disadvantages about this half-wave rectifier, and finally we will discuss about the applications of half-wave rectifiers. Okay. So basically, a rectifier is nothing but a device which will convert the alternating current into direct current. For that purpose, the main requirement is a diode. If we rectify the AC input signal to DC by using a single diode, then it will be known as half-wave rectifier. If we use a group of diodes for this rectification, then such a type of rectifiers are known as full wave rectifier. So these are the main two categories of rectifiers: half-wave rectifier and full wave rectifiers. These full wave rectifiers can be again classified into two types: center tapped rectifiers and bridge rectifiers. Okay, so here in this video we will discuss about half wave rectifier circuit. Okay, so as we have seen, half wave rectifiers we use a single diode, and this half wave rectifier will convert AC to pulsating DC. Okay. The major requirements for this half wave rectifier circuits are mainly a diode. We know that diode is a semiconductor device. At a time it will allow conduction in only one direction. Okay, that can be forward direction. So the diode will conduct in the forward direction. It will not conduct during the reverse direction. Okay, and the second important requirement, that is a transformer. Normally a step down transformers are used. We know that the input supply given to the transformer is normally 230 volt to 50 hertz supply, but almost all electronic equipments works based on the voltage range, that is 2 to 24 volt. So that we need to reduce the voltage to this useful range, so that we use normally step down transformers. So they will reduce the voltage from 230 volt to the required range. Okay, and the third requirement, that is a resistive load. So here you can see the basic circuit for a half wave rectifier. Here you can see the basic three requirements. Here a step down transformer. The supply is given to this primary of the step down transformer. And that is normally 230 volt 50 hertz supply or a single phase supply. The next basic or the important requirement for the rectification purpose, that is crystal diode or simply a semiconductor diode. And the third one is resistive load or simply load. Okay. So first we will give alternating supply to the primary side of the step down transformer. We know that this will be the alternating current. Okay, so the input voltage will be an alternating one. So we are giving in alternating current, we know that there will be two half cycles. First half cycle is the positive half cycle, and the other will be the negative half cycle, and again positive, negative, and so on. So we are giving alternating current to the primary of the transformer. Then during the positive half cycle, this diode will act as a forward biased region. That means during the positive half cycle, this diode will act as a closed switch so that the current conduction is possible. Okay, and what will happen to the next negative half cycle? So during the negative half cycle, this diode will act as an open switch. That means it will not conduct, or clearly it will be like a reverse biased region. Okay, so that during the positive half cycle, the diode will act as an open switch. That means they will allow the flow of current through it. And during the negative half cycle, this diode will act as an open switch, so that current conduction is not possible during the negative half cycle. So that the output waveform will be like this. That means during the positive half cycle, the output waveform will be same as that of the input which is given, like this. And during the negative half cycle, no conduction is possible. That means output will be 0. V0 will be 0. Now output will be there. And during the next positive half cycle, the output will be like this. So these output waveforms are normally known as pulsating DC output. Okay, this is the input waveform and this will be the output waveform of half wave rectifier. Okay, we know that it will be like a pulsating DC output, not a clear straight line. So we can use some methods to make its output as a straight line. So we will discuss about them in detail. So that to get a constant DC output waveforms, or to convert the pulsating DC into a constant DC waveforms, we use a device that is filters. Different types of filters can be used to make the rectified output into a constant DC output. We know that the pulsating DC output means some ripples are present in that output. So filters are used to remove the filters present in the rectified output of the half wave rectifier. Normally capacitor or inductor filters or different types of filters are there, but commonly we use capacitor filters. Okay, so a capacitor can be connected in parallel with the load. This is the circuit diagram for a half wave rectifier with capacitor filter. Here you can see this capacitor is connected in parallel with the load resistance. We know that a capacitor which will blocks DC and allow to pass AC. So that we know that the output of half wave rectifier contains pulsating DC. That means these portions consist of the output wave have some frequencies. That means AC ripples are present in the output of the half wave rectifier. So during the positive half cycle, the capacitor will start to charge. This red colored portion indicates the output waveform with the filter. Okay, so during the positive half cycle, the capacitor will charges at VM or maximum voltage. The capacitor will charge fully charged. Then it will start to discharge when the voltage decreases, and it will be discharges up to the next positive half cycle. Okay, and again it will charge up to the maximum value, and when the voltage decreases, it will discharges up to the next positive half cycle, so that finally we will get the filtered output waveform like this. So that filters are used to provide almost a constant DC output, but to get exact DC output waveform, we can use voltage regulator at the output terminal. Okay. For technical exams, these 11 points are very important, and their derivations are not important, so that derivations are not included in this video. Just its final results are used here to explain their parameters. Okay, first, the parameter, that is average or DC output current. You know that output will be DC, so that IDC will be the output current. It will be Vm divided by pi r. Vm is nothing but the maximum voltage. Average or DC output voltage, that is normally indicated by VDC. It will be Vm by pi. And the RMS value of current, it will be Vm by 2R. And the RMS value of output voltage will be Vm by 2. Here R is nothing but the value of load resistance. Okay. And the rectifier efficiency is normally calculated by using the relation PDC by PAC, and we will get it as 40.6%. Ripple factor, to find out the ripple factor, which is normally represented by the letter gamma, which is equal to root of Vrms by Vdc the whole square minus 1, and its value will be 1.21 will be the ripple factor, value of ripple factor for a half wave rectifier. Okay, the voltage regulation, we can find out the voltage regulation by using the relation voltage at no load minus voltage and full load divided by full load voltage into 100, or we can use RF by RL. RF is nothing but the forward resistance, the value, and RL is the load resistance value. So you can use these equations to find out the voltage regulations. Okay. The 8th point is transformer utilization factor, TUF, will be 0.287. Peak inverse voltage will be same as that of the maximum value of the voltage, that is Vm, and value of form factor will be IRMS by IDC will be equal to 1.57, and peak factor will be 2. So these 11 points are very important for every technical exams, so that we should remember these points. Okay. So let us discuss about the advantages of half wave rectifier. That is very simple and they are very cheaper. And the disadvantages are they use only the positive half cycle, so that the negative half cycle cannot be used. That is one of the disadvantage. And they produce low output voltage because of they are conducting only during the positive half cycle. Okay, so the third point is the output current is not pure DC. So these are the major advantages and disadvantages of half wave rectifiers. So due to these limitations, that we have discussed, the half wave rectifiers are not commonly used, but they are used for the rectification applications and for signal demodulation applications and for signal peak applications. Their uses are very limited, not like full wave rectifiers. Okay, hope you like this video, and thank you.